Here's where the problem gets a little bit more interesting. What we need to do is we need to take our points A and B, and we need to draw a secant line through A and B. Go ahead and grab my straight edge here. So let's see if we can't draw a line through there. Okay, so this line right here is the secant line through the points A and B. Close enough, right? Now, in order to find that equation for that line, we need to take both of our points, A, which is 1, 3, and B, which is 2, 0, and find the slope. Now this guy's not hard to find the slope. You can just take a look here. How far down do we go? How far over do we go? So notice that we go down 1, 2, 3 units. Here's 1 unit. Here's 2. Here's 3. Okay, so we've got 3 all the way down. And then notice the scaling is not quite the same. So notice that from here to here, this is 1 unit. So what we have is a rise of -3 over a run value of 1. So our slope is -3. Now this is an easy one to do because you can see what it looked like visually, but sometimes the numbers don't work out so nice. So what you need to do to find the slope is to take the difference between your y values and divide it by the difference between your x values. Yeah, pretty easy. You guys have been doing this for a while now. So our y values, doesn't matter which guy you start with. I'll start over here. We'll take 3 minus 0. So that's this y value minus this y value. And then we'll go this x value minus this x value. You have to stay in order. So this guy is going to be 1 minus 2. So this would be 3 over -1, which is -3. Just note that you could also do this guy like this. You could have done 0 minus 3, but then you have to do 2 minus 1. I want you to notice that 0 and 2 have to be over one another because they are over here, they're an ordered pair. And then notice that 3 and 1 have to be over one another here because they're an ordered pair over here. So as long as you keep them over each other, you'll be fine. That's all you have to remember. So this will be -3 over +1, which is also -3. So that tells me the steepness of this black line over here. That doesn't tell me the equation. So I need the whole equation. So I'm going to erase this. Of course, you can go back and rewind it if you want to get those numbers again. So we know that the steepness of this line, the slope, is -3. Now, how do we figure out the equation of this line? Well, there's a couple ways we can do it. One way is we can use the formula y is equal to mx plus b. Now we're going to take this -3 and we're going to plug it in here for m. Oops, we need it to be negative. And we get this. Now here's the deal, and here's what you should know why you're doing what you're doing. This equation right here, this y is equal to -3x plus b, that equation satisfies every single point along this line, meaning that every point on the line to the left here will balance for any point on the line. Okay, that's the idea behind it. So, regardless of whether I pick A or I pick B, both of those guys will make this guy balance. Okay, so let's get some room here so we can write this guy out. So since both these guys make it balance, if I pick one, let's say this guy down here, 2, 0, well then this equation should balance, which means if y is 0 and x is 2, then this thing has got to stay equivalent. It's got to stay equal. So that 0 is equal to negative 6 plus b, or b equals positive 6. So that gives us a final equation of y is equal to negative 3x plus 6. That right there is the equation of this black line right here. That's one way of looking at it. You could have also plugged in a instead. Now remember, a is 1 over 3 up. So 3 is the y value, 1 is the x value. And notice if I work this guy down, I get that same b equals 6 value. Now you might not, this form right here, the y equals mx plus b, that's slope-intercept form, because it tells you the slope, gives you the slope value, and it gives you the y-intercept. It tells us where we cross. We cross the y-axis up here at a height of 6 if we extended this guy up. Maybe you don't like using that. There's another alternative form that you can use. And that's y minus y1 is equal to m times x minus x1. Again, it is very similar to the last problem. We plug in our negative 3 for our m value. And now we grab one of our points, either one we want. I'll grab b. And we plug that in. So this is going to be y minus 0 is equal to negative 3 times x minus 2. So that's y is equal to negative 3x plus 6. There's our equation again. Okay. Or we could have plugged in 1, 3. So let's get rid of this guy. Whoops, let's get rid of both of them, of course. So 1, 3 is a point on the line. So again, if we plug all this stuff in, we've got y minus 3 is equal to negative 3 times x minus 1. And if we add 3 to both sides, we get our equation again. Now what we should do is we should use a graphing program to verify that that is actually the correct secant line. So what I'm going to do, I'll grab Desmos again. Here it is. Notice that this right here, this is point A. This down here, this is point B. Notice that I plot them in Desmos just by writing them as ordered pairs. If you want to change the color of them, you just click on this guy and hold it, and it'll bring up all your colors. You can also toggle them on and off by just clicking over here. Our line y is equal to negative 3x plus 6. If I graph that in there, notice that it falls right on both of those two guys right there. And I can go ahead and zoom in if I want to. Gets a little bit glitchy, but not too bad. Okay, let's zoom out just a little bit so we can see the other guy. But this right here, this purple line, is our secant line, and that's what we were looking for.